Hey, this is Andrew Brown, and this is the Free Gen AI Bootcamp. We are back with George and Derek. We covered structured JSON output. Now we're going to cover a different topic, which is agentic workflows, agents. What do we want to call it, George?
Yeah, just agents.
And what is an agent?
Yeah, can we switch to the slide? I have
Oh,
like a
sure.
demonstration. Okay, so this is like the simplest agent you can have, Norbert, which is the naked minion. It can do two things, like can look for bananas or like, do whatever Gru asks it to do. So
Okay.
basically, like you can say something is an agent if it can do like, if there are three things. Like the first thing, it has to have a goal, either it's hungry or trying to obey Gru into doing something. And the second part is can take actions that affect like the external world to do anything. And third thing is it keeps iterating until it reaches the goal. So it's like a Terminator that doesn't stop until like it finds Sarah Connor, for example. So yeah, that's basically an agent. Like it has a goal, takes some actions, and it iterates until it reaches the goal. How this is very different from building a regular LLM application, because a regular LLM app has a specific rigid workflow, so you know exactly how it's going to go. But like the agent is different, and it helps you fix more like or tackle more complex problems because it can iterate. It can keep doing things over and over again until it figures things out, or just like keeps going around like and unable to do anything, basically.
Um, when
Yeah.
when I was talking to other folks about agents, they all were defining it differently. But I think that the definition that I like makes most sense with you with the one that you have here,
Mhm.
because a lot of folks are just like, well, if it has tool use, it's an agent. But like, I guess the whole point is supposed to have if if it has agentic workflow, it has agency, meaning it can do things on its own. It needs to
Exactly.
have its own
Mhm.
iterative loop to be able to do
Mhm.
actions that are not necessarily specifically like statically defined. So like when I was trying to build out agents, I was calling them agents, but you're like, no, no, you're just building it's just basically a static workflow because you can define all the steps
Mhm.
and it's not like it has to iterate back on itself. And so to me, I'm going to pick sides here. I'm going to go on
Mhm.
George's side here and say this is an agent.
Yeah, exactly. Like it has agency because it decides which action to take, and it also has agency when to stop. And to be able to figure out when to stop, it has to have some specific goal it's trying to achieve. And like what one of the challenging things about building agents is that if it's not smart enough to figure out when to stop, so you have to like it can keep going forever if you don't like have some either like a clearly defined goal, or at least like let it go for like 20 or 30 iterations before killing it, instead of like keep going forever. So yeah, it has the ability to iterate and decide like what control its own control for like that. That's the agency part you mentioned, exactly.
And I mean, boot campers have used agents, whether they realize it or not, because like when you're using Windsurf or Cursor or these other things where they're taking multiple steps and
Mm.
they're executing things, that I mean, I would call those like would you call like Windsurf's Cascade write system that's outputting code and changing stuff in the
Mm.
code, or Cursor's whatever they call their thing. I don't know if they call it an
Composer,
agent.
everything. Yeah.
Do they call
Yeah.
it an agent? Do they literally call
Yes,
it JSON
definitely.
mode?
Because like it has like Composer, or like I haven't tried Windsurf yet, but like they have a couple of fixed actions. Like they can grab your code to look for specific keywords and find it in files. They can write edit code. They can run commands and debug commands. They can get the feedback out of like they can create some code changes and then observe the output of the LSP to figure out if you broke something, the syntax is wrong, and then iterate again to fix it. And they can keep going until they reach the goal or they decide to give up, for example.
For StackPack, have you had to create an agent for your product
Mm.
or
Yes, we so far we tried out 3 or 4 different architectures for different things. Like for example, we tried code generation for Docker files initially, and we thought, okay, that would work, but like it never works on the first time. That's why build packs are like cloud native build packs are very hard, because like they promise you that you can take a cloud native build pack and build a container for any application, but every single application is different and has some different environment like requirements in runtime, for example, different configuration paths. And you need an agent because it's a super complicated problem. It doesn't usually work on the first time. So you generate a Docker file, you try build it, you try run it, you test the app, and then keep iterating. And that's why an agent is a good application, like a good solution for this problem specifically.
and when you're talking about build packs, you're literally talking about buildpacks.io, like cloud native build packs here?
Yes, exactly. So it started out with Heroku, I think, and ThoughtWorks, probably.
Is this like a Heroku open source solution?
So Heroku, they contributed to this a lot. So what it does, like they deterministically like check your source code. Yeah, Heroku and Pivotal Labs. So they check your source code, and based on your source code, they have some templates or builders that help you build an image. And these doesn't use Docker files, but they basically try to do the same thing. And the problem with this is they don't work for all applications. So your application has to conform with what they expect to be able to build an image out of it.
Is this like Vagrant? So I don't think I've used build packs actually.
So when they work, they're magic. Like this is how Heroku takes your code and is able to deploy it in a cloud native way.
Well, this it's an image builder for runtimes.
Exactly, yeah, image builder. But the problem with build packs is they don't work for every single app, especially if you have some weird runtime dependencies. And that's why it's a complicated problem. You can't do it without something that iterates and tries like with multiple attempts to containerize your app.
Cool.
Yeah. So if it was straightforward, then you wouldn't need an agent. But like you need an agent for this case because there's trial and error involved. You need to do something, observe, and then do another thing, and so on until the app is working.
Oh, and by the way, I'll just show one more time here. But Derek, if you're curious about it, they had like a tab which was features, and then they're doing a comparison of what it can do versus Docker files versus other possible sources. I'm not familiar with these type of packages.
Oh, nice.
But it's interesting that they show that. So it's not a new project, but clearly it's a robust project here, at least.
Yeah, I've seen it a lot, but I've always been in Docker so heavily that I just really haven't investigated any further.
Yeah. So I switched to the code editor because we're going to give you a code walkthrough to a simple agent. So when I used to learn German, I learned a lot through songs. So I would like memorize a song, try saying it around to be able to pronounce things right, learn new vocabulary, stuff like that. So what we decided to build here is basically an agent that, given like the native language of the person or yourself and the language you're trying to learn and a song name you're trying to learn, it will look over the internet, try to find the lyrics and get the lyrics, extract the keywords or the vocabulary you need to learn, and then explain it to you with examples in the same language and like in your own native language, so you can learn the song and then sing along.
The only German song that I know is 99 Luftballons.
I've never heard of that.
Isn't it Luftballons?
That's why we need this app to learn German, right? To be able to sing the song properly.
It's actually a place right next door to me called Luftballons. It's a balloon store.
That makes sense because like Luft sounds like lift
doesn't fly.
Yeah, Luft. Yeah, I said Luft. Yeah.
Okay. Yeah, flying balloons. Okay. Yeah. So there are almost as many agentic frameworks out there as there are front-end application frameworks. So they're crazy and they keep popping up. Like Pedantic, they just announced released their agentic framework, and there's also LangGraph, which is super popular. But like here, I decided not to use a framework to give you so you can see the details of how this is working internally in the most basic form possible without any abstraction. So these are the packages we're using the API CLI package, the DuckDuckGo search, which is search engine.
So is that similar to I can't remember the name of it, but there's one for YouTube specifically searching it, and so SERP AI. So this is like the DuckDuckGo of SERP AI, maybe, where it just allows you to use an API to grab search results.
Yeah, exactly. Okay. So we use this to grab page titles and URLs, but not exactly scrap the page. We then use Beautiful Soup not Beautiful Soup, HTML to text. So that's much simpler. I used to use Beautiful Soup, but it was too complicated.
And for those who don't know, Beautiful Soup, it's a parser, I believe, like XML, HTML parser, right? Is that right?
Yeah. Yes, exactly. But I found this package that makes this more straightforward. So yeah, I just ended up do HTML to text. So it basically drops all the styling, all the tags, and get you the pure text, which is better for the LLMs to go through. So yeah, we said an agent takes actions. So here we have 3 actions defined. The first one is searching the web, which takes a natural language query and then does a search, returns some results, and basically the title and the URL of the result. So the title is used so the LLM when it's in the observing phase would be able to know what this page is all about, and then the URL because then we feed it to the next action, which is fetching and parsing the actual page. So the second action is getting the page content, takes a URL and makes a web request, and then tries to clean this the web page, stripping it off the HTML tags, getting the text, and then we make sure to only get 4,000 characters because we don't want when you run this agent to blow up and consume gazillion tokens and you get like a huge bill, and you don't want to be too slow. So I'm just like truncating the rest of the characters if it exceeds 4,000 characters.
Do you use TickToken for most of your token monitoring, or do you have something else that you use
There
for
are
that?
a lot of like LLM observability tools you can use.
What-
Because different models use different tokenization algorithms and have different ways of accounting for this stuff. Like, so like same string with like 4,000 characters can be different number of tokens depending on the model you're using. I use Fuse, but like they're all pretty much the same. There are a lot of them. Like there's Langsmith by LangChain as well. They all provide you ways like adding special LLM observability that tracks the tokens, tracks the costs, and stuff like that.
Is this TickToken that you're talking about, Derek?
Yeah,
Yeah.
that's one that I think it was probably one of the earliest ones. Very simple, and I've been using it for a while.
It's just tracking your token usage?
Well, when I used it, it was just to give me the number within my code. Just like I actually didn't tie into any of their cloud or anything like that.
But it
very
tells
simple
you how
stuff.
many tokens are being used with the model, right? Not
Yeah,
necessarily
yeah.
about cost, but just token output.
Exactly,
Yeah,
because
but
some
it
tokens
could
can
do the
correspond
cost
to-
also, though.
Sorry?
Yeah, because like as we said in the previous video, like because some tokens can be like multiple characters long, so you can never do this as a person. Like you have to use something to count them.
I see.
Yeah, okay, so here I'm not counting anything. Like I don't have any observability hooked up here. Yeah, the last action is extracting vocabulary. It basically takes the text and then like splits it. Keeps only like alphanumerical words, like throwing away everything else and then sorting them. Yeah, that's it. So like the three basic actions: search the web, return results, extracting content from a page, and extracting vocabulary from like the piece of content. So we have these actions. We never tell the agent in what order to run the actions. We just make the actions available and add a description for them. And the agent has to decide, like the agent has the agency to decide what to choose. So this problem specifically can be done. I think it can be done with a workflow. It doesn't need an agent, but like, yeah, it fits like as an example of how to do this. And by building it as an agent, you don't have to think a lot about like the workflow. Just give the agent the tools and you let it like go wild. So how we define this, we use like the simplest way. Like instead, you can use Pydantic like schemas, which is much cleaner. But here I just gave it like the expected JSON function, like the JSON input OpenAI expects, which is like, this is a function. And then for the function, it has a name, it has a description of what the function does. And this is very important because this is how the LLM this is how the LLM decides to choose the specific function to call it. And for the parameters, you use a JSON schema to define the parameters. Here it's an object that has a query input, which is this query, and has of type string and the description of what the parameter does, like what this property does exactly, and everything has to be required for OpenAI to work. We do the same for get page content. We expect a URL, and this is the URL of the web page. And finally, for extracting vocabulary, we have text, and we also say, okay, this is the text that you would extract the new vocabulary from. This is basically like how we define the tools to the LLM. And if the LLM supports tool calling, then it would take this input, and whenever it thinks a tool should be called, it will call the tool instead of just replying directly to you with an answer.
Cool. So exactly where I got interrupted. My wife walked in here asking if she's going to go get dog food. So where's the loop? Where's the loop that's happening? Where's that reflection kind of happening? Where
we're getting there.
Sorry. Okay, we haven't hit that yet.
Yeah, so we're basically defining the tools or the actions the agent is allowed to take.
I
So
see.
three of them: search web, get page content, extract vocabulary. This is how we feed the input to the LLM, so it knows, it's aware that these tools exist. But like in our problem here, we have like a couple of custom inputs to the problem, to solve this problem. We have the user's language, the foreign language the user is trying to learn. Here, like my language, I speak English, and I'm trying to learn German. And the song title, which the Philosophen, like the philosopher's song. And we have a system prompt. And we tell it in the system prompt that you're a helpful language tutor, and describe what the agent is supposed to do. And then give it as input like the user language and the foreign language. And as the user prompt, we simulate this by saying like, help me learn about this song, and then the song title, and that's it. Then we define like a flag, whether the goal is achieved or not, because we keep going until the goal is achieved, and we need to know how we break out of the control loop somehow. And we'll limit it to 10 because we don't want the agent to run forever, because it can run forever and consuming tokens indefinitely. So whenever we reach this limit of number of iterations, we stop only if the goal is achieved or if we hit the limit of the whatever the limit we set is. And here it's 10. And this is very important for agents because they can decide to keep going forever. It's up to them. Yeah. So this is the control loop. As I said, like we only stop if the goal is achieved or if we reach the limit. We use GPT-4o Mini because, like, with structure generation, like, yeah, basically, like the part about structure generation here is actually generating the function calls. So what the agent would do is we basically give it the messages input, and then we invoke the LLM here, and it understands that there is a problem and there are tools to help it like deal with the problem. And whenever it decides to call a tool, you get a special message, a JSON message within the response that has two calls. So if tool calls is set, it means the agent is trying to take an action. And this action can be one of three things. It can be searching a web, and we get that by looking up the function name. So the agent decides to use a specific action. It tells us which action it wants to use, and it has arguments for this action as JSON. So what we do is we parse the arguments, and then based on the action's name, we call the specific action internally. So this is how we link between the agent thinking it should search the web and the actual web searching that happens. So it decides to search the web, and it has some arguments to feed this function. So we call the specific function name and give it the arguments, and then get the feedback, and so on. So for every iteration, we try to get the actions, run the actions, return the result, and append the result to the messages so the agent would see the result of the tool call and keep going. So this can be just messages, so the history of messages, or it can be anything, basically. Like you can define a state for the agent, and this is basically the model of how it observes the external world and what it does and the effect of what it does on the external world, and feed it back to the agent so it sees the impact of its actions on the world. Like if you don't do that, if you don't append the message, or if you don't show it the external state, it would just keep assuming that it didn't do anything. Like it's not it keeps forgetting what it did. So basically you have some sort of history encoded somewhere to show it that it's making progress towards solving the problem.
Cool.
Okay, so if it's not calling a tool, then we consider, okay, we achieved the goal because it's not calling any external tools, so it's not taking actions to affect the external world, so we just terminate because the goal is achieved. And finally, we print the final output. So this would keep going until it solves the problem. So the idea here is that, like, if it does a Google search and then try to parse the web page and it doesn't find anything, it would do another Google search, try get a web page. Like so it keep going until it can find the lyrics, and it can extract vocabularies from the lyrics.
Do we have to do anything like tell it to think about tools and have that stuff, or is that built into the framework?
No, it's built in the framework. Like if the LLM supports tools and the API supports tools, it will just work.
For those that are kind of wondering here, and maybe I can just share my screen really quickly and just show a quick example of what that might look like if you're not using a managed service. But I'm going to go ahead and just bring up my screen here, this one here. And so I'm in the Free Gen AI Bootcamp, and I'm just going to make a dump folder here really quickly called agent example. And I'm going to make a prompt document here, prompt.md. And I'm going to just open up Surfer for a moment and just say, we'll clear the conversation. It's like, can you create me a prompt document that shows that uses the React prompt React reasoning. Well, I guess React is reasoning. React prompt engineering technique with tool use. And let's see if it can go ahead and do that. And like write it to the. I'm just going to rename this to agent prompt here, so it knows, and that way I can just say agent prompt, and we'll just quickly do that. And so then we'll just see an example of it because it should work pretty well. I've done this before, surprisingly. And nice. I'm not saying we're going to use this, obviously, but we're just going to see what that looks like, and we'll give it a moment to generate out here.
Yeah, and React is just like a fancy way, like the paper title of a fancy way of saying the agent does something and then observes what it does and then do something else based on, like, yeah.
That's a lot of these prompt engineering techniques are fancy titles, but
yeah, exactly. But it's much simpler in practice. Like if you try to build something with this, it's much simpler than how it sounds.
So we'll just give this a few moments here to generate out. I have Pro Unlimited, so it should go pretty quick. And so if we take a look here, we'll see if this is good. So it says you are an AI system that follows the REACT reasoning, so reasoning and acting framework to solve the problem. So your core principles are this: thought, always explain your reasoning before you take an action. Action, use the available tools to gather information or make changes. Observation, analyze the results of your results. Repeat, continue the cycle until the task is complete. That sounds like it's going to do that repetitive stuff. Available tools. And so here it's saying insert tools. I wish you kind of gave an example of that, but that's fine. We'll go down here for a second. So, for example, step in solving a task, you should think, write your reasoning as thought, your reasoning, act, call a tool using this format. And so what we'll find is that, and here's an example of an interaction. It'll say, find all Python files in the project and count their lines. So assistant, thought, I need to first find all Python files and count their lines. I'll break this into steps. And then it'll say, what action should I take? And so up here, you would tell it like, oh, you have, these available actions. So you could list them out if you want to be very explicit, or inject them like with RAG.
But like FYI, the React paper predated LLMs being good at tool calling. That's why it was necessary back then to define the tools. But now, since most like LLMs are trained on tool calling, you don't even have to include this part. Just feed it the tools. So the prompts are much shorter now.
Oh yeah. So like, so what part of it? Like, do you not even need this part?
You don't need to tell it this is how the tools look and you have to call tools. You don't have to mention this. Like, it would decide on its own to pick tools. And that's like basically because things are moving really fast and LLMs are just like getting better at doing that without you having to prompt it to.
Even smaller models, or
if the model supports tool calling, like if the model is trained for tool calling, then it should work out of the box.
But so are you saying this mostly for like managed large services that we can't run locally?
No, this was like the time they released they published this React paper, models were not like doing that by default, but now most models call tools by default. So you don't need to tell it what is a tool call. Like, it knows there are tools that you can use.
Okay. But would you still have to tell it of what tools are available for it to use? Not necessarily.
No, you don't. Not in every case. Like, we found like in practice, OpenAI is really good at this. So you don't have to do this if you're using OpenAI. For Anthropic, you also like, most of the times you wouldn't need to do that, but in some cases, Anthropic, because they don't use proper structured JSON generation, they mess up the function calls. So at some point, we figured out like, okay, to make Claude better at this, we have to tell it more about tell it more about the tools so it doesn't mess up the JSON generation.
But I guess my thought is that you are still providing it the tools that are utilized in another structure. So wouldn't that be injected into the prompt?
No, this is like, I'm not sure like how they do it internally, but like here, when I'm prompting it, I'm adding tools to the like create prompt.
But what I'm saying is like, if you are defining them here, it has to tell it like what they are. Otherwise, how would it know?
Yes, but they do it internally in a way better than I would in the prompt. So like in the prompt, I never mention tools, but like internally, they feed it to it somehow. Like, they let it know there are tools somehow.
Yeah, for Amazon Bedrock, they have their own managed agent thing, and we can see there's a way to actually see the document. It literally is like, these are the tools, but I don't know if it describes the format of the tools, but it definitely explicitly injects it. So, but anyway,
yeah, I think it does that internally somehow. Like OpenAI, they do that. They like, it's part of the API. You'd see there are tools that you can feed in. Okay, so let's run it.
Cool.
So UV1. So I'm using UV. It's a new like Python package manager. That's why I use UV run instead of like Python AgentPy.
One of our boot camps mentioned it, and so I mean, it's not an alternative to Conda, is it?
I've never used Conda, so I don't know. But like, yeah, it manages packages, virtual environments, and Python version. So it does like a couple of things you used to do separately.
That's Conda. Yeah, so that's pretty much the same thing as Conda.
Well, but sorry, does UV do environments as well?
Yes, it manages like automatically. It does like creates a venv and a virtual environment, and it like assumes this virtual environment, like sources it, and then run the command.
Is there any advantage of UV over Conda, Derek?
Not that I know of. I pretty much stick to Jupyter notebooks overall, and a lot of that kind of stuff's abstracted. So I don't bother it much, but I've heard really good things about UV so far. A lot of people with Conda, I don't think many people use Conda outside of data science workloads. I have a feeling that a lot of people who are using pipenv and stuff like that have probably skipped Conda and moved straight to UV. Whereas, people using Conda probably will never leave.
Some people say it's fast. Like from my experience, it's as fast as NPM, for example, versus NPM. It has some caching mechanism that makes installing packages faster. But I've never used Conda heavily to know how fast it is compared to it. Yeah.
It looks
Yeah.
like its selling point is 10 to 100 times faster than Pip. That's their selling point for UV. That's interesting. Sorry,
That's a pretty big range there, 10 to 100. Like-
times. Yep. So
Mm.
I don't know.
Yeah, it's like PNPM and NPM.
Yeah.
Okay, so you see here, like I gave it the the input, which is like I'm a native English speaker. I'm trying to learn German, and the song title. So what it did is it decided to call search web with this input. So it came up with Die Philosophen lyrics. I didn't add lyrics as a song title, but it came up with that because it thought it's a good way to look for the lyrics. And this returned like 10 pages with different titles.
Okay.
And it decided to pick one of them, which is this link call get page content. So it decided to search the web, and then it checked the output, and then picked one of the titles and copied the URL.
Is this summary built in, or is this what you print out?
No, I just
coded it in?
it out. Yeah.
Okay, I see. Sorry. Yep.
Yeah. So it decided to call the action or like function get page content with the input, which is like the URL of one of the pages, and then it parsed it and it read the page. We don't see that here, but then it decided to call extract vocabulary. Like it decided, okay, these are the lyrics, it's good enough, and it called extract vocabulary of the like song lyrics. This is the song lyrics. Der Mann Aristoteles verblödet doch ich erzähles. Yeah, and then it keeps going, and then it extracts the vocabulary here, like all the words.
Mm-hmm.
And then, okay, so and this is the output, the final output. So let's dive into Song Die Philosophen by Wise Guys. I'll help you explore some new vocabulary extracted from the lyrics to enhance your German learning experience. And it picks like one word at a time and then translates it directly into English. And it gives me an example in German. So aber, which means but. So let's take besoffen, for example. Besoffen means drunk. So it came up with an example. War so besoffen, dass nicht gehen konnte. So I was very drunk that I couldn't walk. Yeah, exactly. So,
remember that game Co-op? This makes me really think of that, where you have to use the KWOP keys to guide a drunk guy home. I think it was on like not Newgrounds. I think it was on eBaum's World. Anyway, sorry.
Yeah. So basically, like tried breaking it down, and then it adds a fun fact about the song, which is like the song humorously portrays well-known philosophers like Aristotle, Diogenes, and Plato, suggesting they all were drunk, and their ideas were influenced by their drinking habits. It mixes philosophy with humor, pointing out that the absurdities in their lives and the thoughts of these great thinkers. Cool. So, do you want to try another song? So, what was it called? Luftballons?
99. It's the English version is called 99 red balloons, but it's weird because the other one is called Luftballons. 99 Luftballons.
Okay, let's try this one.
Very, very well-known song.
Okay, so it looked up 99 Luftballons lyrics, came up with a couple of options. Yeah, these are the lyrics. Hast du etwas Zeit für mich? Do you have time for me? Dann singe ich ein Lied für dich.
That sounds right.
Von 99 Luftballons auf ihrem Weg zum Horizont. What is this? What?
So now, how do we generate a karaoke track now?
How generate what?
How do we generate out the karaoke backtrack for this now?
Yeah, we need to do that. Like we need to model that. Yeah.
Well, I guess you bring Whisper and do the timings, right?
Yeah. Yeah, I think that's it. So in this case, like it didn't go back and forth.
Sorry, for those that are wondering, when you output from Whisper, I believe that gives you all the time codes of all the singular words. And then with FFmpeg, what you could do is stitch like fill in blanks or whatever, or or just at least know where to put the words on the track. If you let's say you picked out an audio track and you hope that it exactly matches, then you could put the words exactly.
Well, that's how Descript and Audiate and like a million other ones work now, and you can go in and actually edit your time code. So if I said something really, really dumb in this, you could go and delete like entire sentences of what I said pretty quickly. I mean, hypothetically.
We should try a much less known song so it can iterate. Like, could you have an example? Maybe a Japanese song.
Well, we'll do another target language.
Yeah, if we can. Like your.
Sure. So let me say, I'm trying to remember the name of the song. There is well, there's a really famous song from in Japanese that everybody knows that's from an anime, and it's from Evangelion. But I'm not sure how it'd be like the Evangelion opening theme song. Everybody knows that one.
Maybe like I don't know this one.
Well, I can give you one that's more obscure if you want.
Yeah, we need something more tougher to watch it.
I'll give one that's not as well known. Just 1 second here. I'm just trying to
Does
find
it, like Attack on Titan, Titan open theme have like lyrics, or like just like they have a lot of like multiple ones.
But there's one called there's one like I actually know the lyrics to, but or most of it anyway.
Yeah, which one?
I just can't remember the freaking it's Antenante. So the song is Antenante. I'll put it here in the private chat here so you can grab it. And
So,
it's by what's her name? Riria. It's like, here you go. So here, I just gave it to you in the chat.
Antenante. Okay. I think I got it right. Antenante. Okay. Let's see if this is like vague enough.
Well, yeah, you gave it Japanese here. Let's see.
Antenante song lyrics.
It says, yeah, it's getting the right person. Yep. On almost every case, it's gotten the right one.
Did it get the key? Did it get it in English?
I imagine if we know the song,
it got it in English.
Oh yeah. So, well, because the thing is, like, the websites could have English versions of them, right? So how would you know that it would grab it, or like, how would you know that it would output in Japanese?
Okay.
I was reading the other day about how OpenAI and others are trained so heavily on the English language that it's almost always going to opt for it if it's available.
Yeah. Let's try again. Like, I tweaked the prompt a bit.
And you're using Mini, of course. So Mini needs a little bit more. It's fast, but it needs a little bit of help.
But like, is this a single word?
Well, just go to the top. Just go to the top.
Maybe
the
splitting.
Start of the song, like in your output there, and bump it up a little bit because I can't read that small.
Maybe it's the way I'm splitting the characters with like I'm splitting the words with white space.
So well, let's just say it looks right. Antenante, do demo e, zen ski janai no ni ski nahaz zunante. Yeah, it's right. Yep, it's right. This is
but we're splitting it wrong. Like the extract keywords in the wrong way.
So what do you want to split for words?
Yes, exactly. And apparently, like, these are not like white characters.
Scroll up. I'll tell you, because sometimes this is where it has a bit of a trick, right? Like, it's a bit hard for it.
Yeah. So here in this tool, we're splitting like this one. We're split.
Sure.
By white spaces.
But if you make it a little bit larger, I can tell you like if it's chunking it correctly or not. But you got to make it a bit bigger. So the challenge is that some of these things are here like. Here. No, that's a sentence. So
yeah, it's not a chunk.
Some of them are stuff, but like the other issue is that it also would have to take some of the words and put them in dictionary form, because they are, they're conjugated, they're modified, or things like that, right? And because it's a high context language, it can sometimes be confusing which part of it. There's also fixed expressions, right? So it might go, okay, this is a word, but maybe we'll give you the fixed expression because it's so darn common. And so this is where we have the challenge of the Japanese language because of that parsing, right?
I mean, Andrew tried giving me a Japanese primer, but like it didn't work, as you see. Like I can't even split words.
So, but yeah, I mean, yeah. It's so like my thing was that if you give it too much to do, you have to break the task down smaller so it'll actually individualize the words. Otherwise, it won't do it. For Japanese, for English, maybe that wouldn't be an issue, but for Japanese, you really have to give it smaller pieces of text. Otherwise, I don't know. It just maybe needs more thinking power, so it has less to chunk out. I don't know.
No, I think here the problem is my implementation of extract vocabulary. Like it realized that I do this properly and just trusts the input. If I give it more granular actions.
Well, how are you splitting? How do you know that?
Yeah, here it is, like line 33.
Well, but it just says text.lower.split. Yeah,
exactly.
Well, what's it splitting on? An empty space?
Yeah, I think empty space.
In Japanese, they don't use spaces.
Yeah, that's it. Like even if I'm trying to select the character, I can't. So there are no empty spaces. Yeah.
Yeah, it's almost.
So I have no idea how to split. Like I split it character-wise, right?
It's not even character wise. It looks like it's almost like it's line by line for what it is, because the only time there would be a line would be when a new line occurs. It would be the only time to split. So I
Exactly.
think that's what's happening here. It's that whatever
Yeah.
was here, it's splitting it based on the lyrics,
Yeah,
whatever
so
the
my
gap between
implementation
words.
of this is not generic to all languages
Mhm.
currently. Yep.
So I guess my question is like, is this something that would be easy or hard to modify to get the agent to fix?
So here the agent is like outsourcing this function to us. It
Mhm.
like it does the splitting, like it makes us split it on its behalf. What we can do is like basically like do this, like just remove the tool, and then maybe it will be forced.
But I
to do
guess,
it
but
itself.
would you be giving too much responsibility to the agent? And should you really have another agent call that is responsible for splitting the words out?
Maybe let's try like now, since we're not like giving it a tool to split. Maybe it
This
will do
is-
the splitting itself.
This is where I had an issue where I had a large piece of text, and then the next thing, this is the original project I was talking to George about, where I take a movie transcript and I iterate through it. Whereas once you had too much text, it would still not split it correctly, and then I had to write a validator to validate it. It was just this endless loop of trying to get it to do what I'm asking it to do.
So here it decided like to sample stuff, like take a bit. It did better job splitting, but it's not comprehensive.
Yeah, and that's the problem. It's either not comprehensive or it is comprehensive, but it doesn't actually split the words properly.
Yeah, so we need to have like a smarter way of implementing the splitting, or some of these agent frameworks supports multiple agents where you can define an agent just for splitting Japanese, and then like outsource the task to this agent and get the result. Or it's just a fancy big tool that can keep iterating.
But the point is, the main loop of the agent will iterate over and until it's done, right? But the point is that it's just giving a subtask to another agent.
Exactly.
To a very
So breaking down the tasks and the
task is a function, right? A more robust function. Sorry. Yes.
Exactly, it's a function, but the function is intelligent. It keeps iterating itself. Like it has its own control loop as well.
Cool. Well, yeah. I mean, I can see a few little tweaks to be made here, but yeah, it looks like we have a way of learning. I guess the next part would be if you could get structured JSON out, then you could build a UI for it, and voila, boot campers.
Exactly.
You got yourself a homework assignment. But thank you, George and Derek, for round 2. And yeah, we're gonna have a lot of fun learning about 99 Luftballons, if I said it right.
Yeah.
But that's it. And any parting words for our boot campers?
Not really. I think that was a lot. It was a lot of fun, actually. I'm really, thanks a lot for bringing us on, actually.
Okay.
Parting words for you, Andrew.
I guess I'm hungry as much as Derek and George is, and I'm gonna go get lunch. We'll see you later, folks. Ciao, ciao.
Later.
Bye.
Adios.